In this video I would like to demonstrate the estimation of ARDL approach to cointegration, or application of ARDL approach to cointegration in Eviews and Microfit softwares. I will not do separate analysis in these two softwares. However, I will do one analysis using Microfit and Eviews. That said, I will do part of the analysis in Eviews and part of the analysis in Microfit software. Now let's start with Eviews. Now I have here a set of data to pick from. I will only pick 3 variables out of this list of variables. These are transformation of variables of these short named variables here. Now the first step, as you know, to conduct the ARDL approach to cointegration is to see if there is a long-run relationship. There is a long-run relationship between or among my variables. To do that, I need just to estimate a simple OLS equation, and for that I have earlier saved the model, or earlier typed the model myself so that I could save time on the YouTube recording process. So I will copy this into my estimation menu and I will explain what these are basically. Now what I'm trying to estimate is this is basically the first difference of oil consumption, so that's my dependent variable, constant and trend terms. Now it's the choice of the investigator whether to include trend and constant. However, in this case I would like to include them because of my data has a trend, and constant we will see that whether this will be significant or not, but trend is will be a significant term in the model because of the trending characteristic of my data. Now GDP is my second variable, and I have taken the first leg here in levels. EMP stands for employment, first leg, and OC stands for oil consumption, and this is also first leg. So these are the first legs of my 3 variables. So I have 3 variables basically. Now next comes is the first difference of GDP. In basically this is the first leg of the first difference of GDP. Leg 1, first difference of GDP. Second, leg 2 of GDP, first difference. In other words, second leg of the first difference of GDP. Similarly, employment, first leg, first difference of first leg, and second leg of the first difference of employment, first leg of the difference of oil consumption variable, and then second leg of the first difference of oil consumption data here. So I think estimating this equation now, and I will test after the estimation I will test whether taken together these 3 variables are jointly significant or not. Now in my estimation sample period is from 1999 and 2010, and rather short, so I will demonstrate another video with a longer variable sample time, and then with more variables basically, and we will choose from the menu least squares method, or OLS. Now I will click OK to estimate the model, and here our model. Now to the contrary, my trend is not significant, my constant is not significant, but we will leave this because my economic variables are have trending characteristic. Now we will ignore the diagnostics checks for now. What I need to do is to find the coefficient terms for these 3 variables. In other words, how they are denominated or how they are noted in Eviews output. So to do that I'll go to Eviews and check representations, and here they are So C3 is the coefficient of GDP first leg, C4 is the coefficient of my first leg of employment, and oil consumption is the coefficient of, sorry, C5 is the coefficient of oil consumption first leg here. So I need all these three legged values, and I would like to test whether they are taken together jointly significant or not. So to do that, I'll go to view, go to coefficient tests, and I click volt coefficient restrictions. Here I will type now first coefficient 3, that is GDP, coefficient 4, and that is the employment coefficient, and coefficient 5, that is the oil consumption coefficient. I would like them to be equal to 0, and this is my null hypothesis, and my hypothesis is that they are equal to 0 jointly. Now I click OK and see if I can reject hypothesis or fail to reject. As you can see, F statistics from the volt test and is actually significant at 5% level, so it's less than 0.05. Now this value is important for me. I'll ignore the rest. This is the key value I'm looking at. Now I will take this value 705, I will take this value and compare it against the critical value provided in this table here. This table is the pre-populated table by Pesarin et al. 2001, page can be found in page 294. Now this is an F table, and this table are the critical values for bounds testing. In other words, if my F statistic, which I found here, is greater than this upper bound value at 95% level, any of these values, then I have cointegration among my variables. However, if my F statistics is lower than this lower bound values, then I do not have cointegration, or my variables do not have long-term relationship among themselves. And if the value is between these two values, then the results are inconclusive, or in other words, I should check this cointegrating relationship using another method, probably Johansen-Gislius or Toda-Yamamoto method, or many other methods available. So to do now, in our case, to do the bounds testing approach, I have to take this variable, so it's 7.05. Now I go back to table, and if you remember, I included actually intercept and trend. So this is the set of variables I should look, not this one. This one has intercept and no trend, so in case I didn't include any trend, I wouldn't take this. Or if I do not have any of this, then I would look at this table. Now since I have included intercept and trend in my model or equation, I will look at 95% level and these values. Now I have three variables. Out of these, two of them is my regressors, so these are, k is equal to 2, basically my forcing variables. I go across these values, and at 95% level, upper value is 5.87, and I have 7.05, which means it's greater than this critical value. So I have, in other words, my data has, or have, in fact there are three data, so three variables, they are cointegrated, or they can have, or they might have long-run equilibrium relationship. So now I have now estimated that and I have now found that my variables are cointegrated, or they have long-run common association, or they have association in the long run, or they move together in the long run. Now I can estimate ECM model or error correction model and see the causation, short-term and long-term, or short-run or long-run causation between them. So I'll go to Microfit to do that. Now I will demonstrate that part of the analysis in Microfit, and here is the same data that I analyzed earlier. This is the GDP data, this is oil consumption data, and I have the employment data somewhere here. This one. So these are employment data. Is thousands. Sorry, these are levels of number of people employed in Russia. Actually, this is the Russian data. Now I go to here. Once I have the data here, assuming that you have transferred the data, you go to multivariate. You go to univariate, and from the menu here choose the ARDL approach to cointegration. Now looks like I tested it earlier, so I will keep this as it is. And you have to specify the sample period. I will specify full sample period excluding 2011. I don't have data for I think GDP or employment for 2011, so I'll choose 2010. And as you can see, this is the ARDL approach to cointegration. Now I have to specify the maximum lag I would like to include in my data analysis, or in my analysis. So I will specify 2. I put 2. I have annual data, so I no need for entering 4 years of data here. As usual, we should start with 5 or 4 lags and then go down to the lag parsimonious model, or in other words, reduce the lag to get the best model. Now I've done it earlier, and then I found that 2 lag is enough, and 2 lag is sufficient to get a model working. Now here is my equation. Basically I will enter in this order basically my variables into the estimation menu. So OC is the oil consumption, GDP, and now employment, and my deterministic values or variables. Input stands for C in Eviews. In other words, this is a constant, and T is trend. Now you need to specify them. You need to basically specify them in process, and by going to constant you enter input and press OK. I've done it earlier, so I don't have to do that. And to get the trend in the variable list, you have to press time trend, and then type T and then press OK, and it will create actually the data, time trend data and input data here. So I'll go back to my single equation estimation menu, and now since I've typed my model and variables here, I will click start. Now promptly my Microfit is giving me this menu. This is an ARDL order selection menu. I prefer choosing SPC criterion, or you could actually choose a key information criterion if you wish, or any other available criterion here. So I'll go to number 4 SPC and click OK. Now it has, presumably it has selected the best lag for me out of 2 maximum lags, and I'll click first display the estimates of the selected ARDL regression. So I will now see my ARDL regression here. Now this is the ARDL 220 model. So my SPC criterion basically selected me the best model. According to it, the model or the criterion, this criterion, the best model I could have is ARDL 220. In other words, it has taken 2 lags of my oil consumption data, 2 lags of my GDP data, and no lags for my employment. Okay, good. Now this is the ARDL model itself. Now I can see trend is significant, input is not significant, and I'll ignore the rest. Now I'll go to the diagnostic test. This is an important one. You shouldn't ignore this, but in some books the authors suggest that you can ignore the diagnostic, especially heteroscedastic to serial correlation, because this is a distributed lag model. But you shouldn't basically. So I failed to reject the homoscedasticity according to the F-test of the residual homoscedastic residuals. I have also, I do not have any serial correlation. I failed to reject the null hypothesis of no serial correlation, and however I reject the functional form. However, in fact we can ignore this because the functional form is not a big issue in ARDL. There could be the case that I should take the logs of these values, or any other transformations might be useful to have this value non-significant. However, we ignore this at this stage. This is a basic estimation method. I will do more advanced video on this later. So basically we can say that we passed the diagnostic tests and we don't need this output at the moment. What we need is actually long run estimates, so long run coefficients. So I'll close this menu and I'll cancel this again, and now I press number 2, display long run coefficients and their asymptotic standard errors. So click OK. Now this is the key, one of the key outputs, and this is the same model. However, it's actually estimated long run coefficients for my model. Now in the long run, oil consumption is significantly affected by the GDP. However, it's not affected by the employment, and my input is not significant. My trend is significant. Interesting. Now, long run causation. So there is a one-way causation in the long run, which runs from GDP to oil consumption at this stage. So you will copy this. If you wish to do that, you just simply highlight and click Control Copy, but we will not do this here now. So after you copy it, close. Now again cancel and click Display Error Correction Model. Now this is important, ECM model. Okay, and this is my ECM, the same model, same ARDL model. Now interestingly and most importantly, ECM error correction term is significant and is -3, which is greater than smaller than -1, or greater in absolute value than -1, which means it's a quick adjustment to the disequilibrium of last period. In other words, if this value is about -1, it takes 1 year or 1 period to go back to the normal adjustment. So you should have significant negative ECM term in your model. Otherwise, there is no long run relationship basically among your variables. In our model, I do have. In other words, my variables are cointegrated in the long run, or have moved together in the long run. Basically, if there is in the short run, there could be deviations from the equilibrium. However, in the long run, they adjust and they move together again. So this is a proof. This value is a proof, and this is significant. Now let's look at short run causations. So oil consumption is affected by its first leg in the short run. Okay. However, current GDP consumption doesn't affect my current oil consumption, though last year's GDP consumption does affect my current year's oil consumption. Now that's an interesting, and that's actually negative. This is a good thing. Interesting. So there is a negative causal relationship between them in the short run, basically 1 period ahead. Alright, so last year's GDP consumption actually increase in GDP consumption, increase in my GDP of last year reduces my this year's oil consumption. That's interesting relationship, and oil employment has nothing to do with my oil consumption. Basically, it's not a significant value. It has an absolute value positive relationship. However, it's not significant, so it can be dropped basically. Now I have trend, significance, and input is not that significant, so I could actually ignore the constant. Basically, I could drop it. However, there is no bounce testing for model without it constant. Now I do not have to do the model checking here. Now this is, however, is important, my ECM. So these are the same values you could see here. Sorry, this is my ECM or long run. This is my long run equation, and using this long run equation I estimated ECM, and basically ECM is error correction term, which is the residual of my long run what you call this, long run equation. This one is actually the original estimate that we earlier estimated. This is a long run equation, and this is my dependent variable, if you remember, and dependent variable minus all the sum of all the independent variables gives you the error. So that's the error that we regressed against DOC, in other words, difference of oil consumption. So with this I will end this video, and I will record another one later, and I promise to do that in a short time, and hopefully you'll find this useful. And if any questions, you can leave a comment, and all the errors I made here, mistakes, are mine, and hopefully you will correct them if you spot them. My brain sometimes malfunctions. You probably noticed this during the video. Alright, see you later then.